This is the solution video for section 7.4, problem number 6. All right, so we see that we're given here a graph of lowercase f. All right, and so now it says the graph of the function f consists above consists of a semicircle, right? So right there, and three line segments. So right here, and right here. Let g be the function given by g of x equals the integral from -3 to x of f of t dt. All right, so as soon as we see an integral defined this way, right, we need to make sure we understand that that tells us that g prime of x will be found by taking x and plugging it in for t and then multiply by the derivative of x. So so we're plugging x in for t, times the derivative of x would just be 1. So it actually tells us that g prime is f. So this graph, yes, is of f, but it's also of g prime, right? And so that's a really important thing that we need to recognize, all right? So now it says find g of 0. Well, g of 0 is going to be, well, g of x is defined as the integral from -3 to x. So that would be the integral from -3 to 0 of f of t dt, right? And so all that means is the integral, so the area under the curve from -3 to 0. So it looks like we have this shape here, which is actually just a trapezoid. So we're going to take 1/2 base 1 plus base 2 times the height. So base 1, that would be the vertical height right here on the left. That is 2 times, base 1 plus base 2, which would be the vertical height here, which is 1, times the height, remember, which is the horizontal width of that interval, which is 3. And so I have half of 2 plus 1, so 3 times 3. So that would be 9 halves. So g of 0 is 9 halves. All right, so that's the first answer. All right, then it says find g prime of 0. So g prime of 0. Now remember, this graph is g prime. So g prime of 0 would very simply be f of 0. So this is a graph of f. So we just go to the graph when x is 0 and the y value is 1. So f of 0 is 1, which means that g prime of 0 is 1. All right, so that's part A. All right, now part B says find all values of x in the open interval -5 to 4. Remember, open interval, that means cannot be at one of the endpoints, at which g attains a relative maximum. All right, so forget about f for a second. This is a graph of g prime, right? So g attains a relative maximum when? Well, let's think. Draw a picture of a relative max, right? If this is a graph of g, then relative max occurs when g prime, right, changes from positive to negative, right? So g prime changes from positive to negative. So now this is a graph of g prime. So when does this graph change from positive to negative? In other words, above the x-axis to below the x-axis. Well, this goes from below the x-axis to above the x-axis. Then it's above the x-axis. Here it touches the x-axis, but it's above on both sides. Then here at x equals 3, we are changing from above the x-axis to below the x-axis. So g prime is changing from positive to negative. And so we would say there is a relative, let me move that up. There is a relative maximum at x equals 3. Why? Because g prime changes from positive to negative. I wish I knew how to spell. Positive to negative. All right, so that's it, right? There's a relative maximum at x equals 3 because g prime changes from positive to negative. All right, and so that is number 6.